Hey guys, how's everything going? This is JSer. In this video, let's solve number 417 from LeetCode. It's Pacific Atlantic water flow. Given an MN matrix of non-negative integers representing the height of each unit cell in the continent. The Pacific Ocean touches the left and top edges of the matrix. So this is Pacific, here is Pacific, and the Atlantic Ocean touches the right and bottom edges. So this is Atlantic. Water can flow only in 4 directions, up, down, left, right, from a cell to another one with height equal or lower. Well, this is obvious, right? Water can go up, it can only go down. Maybe the height equal means like a little of wind. Yeah, water can go along the same height. Find the list of grid coordinates where water can flow to both Pacific and Atlantic Ocean. For example, here, the height. This is the height of the continent. 5 here, 5 here, obviously could flow to Pacific because it's connected to Pacific and both Pacific and Atlantic. 4 could go to Atlantic, and also it could flow to this 4, and this 4 could flow to Pacific. So this 4 is okay. But these 3, it could flow to Pacific, but it cannot flow to Atlantic. So the idea comes to my mind is that if the water can flow, means if water could flow to another cell, then it could flow to anywhere from that cell, right? This is kind of obvious, but it means that if we think backwards, the where this cell could flow to could determine possibly determine what the cell could connect it to this cell, right? It means for this one here, actually if this cell could go to Pacific, and then this specific cell around it there will be 2, 3. Any cells taller than it could go to the cell, go to the Pacific, right? So let's say a state for a cell means that whether it could go to Pacific or go to Atlantic or neither or both, then this state value for cell could affect the cells around it, right? Just by comparing the height. This gives us the approach that we could just mark the matrix with a state value recursively. It means that if we this cell could flow to Pacific, right? And then we check the cells around it. Then 2 is taller than it. Then these 2 could also go to Pacific. Also, these 2, these 3, this 5 could also go to the Pacific. And 3 could go to Pacific, but these 2 is smaller than it. But this 2 could go to Pacific because these 2. So it's like a marking game. We mark all the possible the cells that could go to Pacific and also go to the Atlantic, and then at last we could get the final result, right? So we have 4 state value, which means that neither or go to Pacific or go to Atlantic or both. So we could use a 2-bit number to do this, to represent the state, right? So the idea is that I would say const can flow to Pacific equals 1, can flow to Atlantic 0b binary 0, 1. So we could use the bitwise operators to help us make the process concise. Okay, now we would collect the result by mark, right? To create the marked matrix of the status. So I would say marked is before it we caches the rows matrix length const columns equals matrix dot columns. Oh no, 0 dot length. We initialize the new array, rows fill with 0, and then map with new array, columns fill 0. Great. Yeah, this is the marked. And also we need to, if we just do it recursively, say we move from 1 to 2, and then 2 checking the surrounding cells equal to 1 again, right? So obviously we need a visited map to hold the visited state like this. Okay, visited. Okay, I'll make it clearer, though it doesn't make any difference. Means could not flow anywhere. 0 0 const can flow to both 0 b 1 1. We initialize with 0. Could not float anywhere. Well, it equals to 0. Okay, now we create the walk method. Every time we walk on something, we would get a coordinates and get the flag, whether we check the can flow to Pacific or not, and then we would accompany it with the visited matrix, right, to avoid the infinite loop. Okay, this is the walk method, and what to do. Okay, we could mark it, make it mark. It's better. Okay, and then we have some init values, right? We already told that the top borders and left borders can go to Pacific. So we use a for loop. For the rows first. For the rows means we go to this direction. So we check Pacific for this border and check Atlantic for this border. Yeah. So we would mark a row I. J means the 0, and these can flow to Pacific and visit it. And also we mark this one is I columns -1 can flow to Atlantic, visit it. We'll do the same for let I equals 0 smaller than the columns. It means we're going to this direction. So mark 0 the first row. I. Also we could go to Pacific with visited. Mark no, this should be rows -1 I can go to the Atlantic and visit it. And this is the mark. Let's log the marked first. And in this mark, first there might be invalid values while we are walking, right? Maybe out of the boundary. So if I smaller than 0, j smaller than 0, I bigger than the rows, or j bigger than the rows. For these kind of invalid coordinates, we just return. We do nothing. And also, if it is visited, I and j, we return. We should not work on it again. And so if it is not visited, and we could just now we set it to visit it to 2, set it to 1. Of course, when the mark is down, we set it back to 0. And in this visit, what do? We marked the ij. Here we use or, right? Or the flag. Yeah, we set the flag. And then okay, then the flag, and then we check the boundary, check the coordinates around it, right? So first we check the coordinates left to it. So if j is bigger than 0, then it must have a left cell. We check it, and if check the left cell if it is taller than it, and also it is not marked as this flag, right? If it is not marked as this flag, we wait a minute, do visited. Oh yeah, we don't need to check the value of the if it is marked or not. We only check if it is visited or not. Because if it is marked, then it is already visited, right? Yeah, so we only need to check that if it is taller than it or not, and visited. Yeah, if it is not visited, yeah, means if it is not visited and higher, then then mark it. Okay, so if oh, this is not it should ij. I'm sorry. If visited I negative j negative 1, the left one. If it is not visited, okay, and it's taller, so it means the matrix I j is bigger or equal to current value. It means matrix I and j. Then we mark I j negative 1 with this flag and visit it, right? Yeah, and we would copy this for 4 direction. I bigger than 0, so this should negative 1, negative 1, negative 1. J could be the same. Okay, j negative 1. Yeah, this is true for I. And then we do j if j is smaller than columns negative 1. We check the cell to the right. So here should be plus, plus, and plus. Also, this should be I smaller than rows negative 1, plus 1, plus 1, plus 1. There's no negative 1 here. Yeah, this is. Let's take a look at the marked result. This is the marked array. We see that we get the 3. 3 means both, right? This is the both. So 3, 3, 3, 3, 3. Yeah, this is actually exactly for the result for the example. Let's just now just do we just collect the result after it, or we could just collect on the fly. If we find mark, yeah, we could actually collect here, right? Let's say the result here. If marked I j equals to oh, there might be duplicates here. Okay, anyway, I'll write the code. If it is the can float to both, we collect the result. And we log the result. Actually, I think there is a conflict. There would be duplicates because because here we check only visited. In a second round, it is not visited anymore. So rather than visited here, I believe that we should check with marked use bit and the flag. If we did already set the flag, we don't need to check it again, because the flag means that is already visited before, once before. Okay, so I'll rewrite it to marked and flag. Marked flag. Marked flag. Let's console log the marked and the result. This is the marked and this is the result. You see that there's still duplicates. No duplicate. 8, 7. So we got some duplicates. We got 0, 4 as the duplicates. 0, 4, 1, 4, 1, 3. Yeah, we get it. And then we get 4, 0, 3, 4, 4, 0, 3, 0, 3, 1, and then we got 0, 4 again. Why? But our approach should be on the right direction, I would say. So when we set, okay, when we mark a flag, why would we push it again? We only mark, I see. Because here, when we are mark, there is already duplicates for this the corner cell and this corner cell, right? So actually, I would not collect the result here, but use a for loop to check the rest. I think this should work. Yeah, this should work, and then we return the result. Come on, pass. No, empty. Shit, empty. Okay, you win. If matrix.length is 0 or matrix I hate these edge cases. Wrong answer. Ooh? What? Oh, we got a wrong answer. Why? We console log marked. What does it mean? 333? Yeah. We why is this 0? Huh? Wait a minute. Zero 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 330. This is weird. It should not be 0. There are some mistakes about the marked and the visited. Test result actually works pretty great. Oh, wait a minute. The first row, it should not. Okay, here. It should not. We got 333. 30300. Why it's all 0? It should not be 0. I0 columns -1. It means go down. Atlantic. Mark. Ah. Oh, set it here. Allow me to log down IJ flag. It seems that the coordinates, there's never been a, because like there are 3 elements, there never been an index of 5 or 4, which is not cool. Let's log it here. Oh shit. God, yeah. Come on. Yes. Finally. Sorry, it totally I got a typo here. But anyway, this is I think I've solved it with a pretty decent approach. Hope it helps. See you next time. Bye bye.